So as I'm looking at this first one, all right, remember 3-1 is going to be your one-step equations. So basically, if I were to give you this picture, all right, and say find x versus this, the area of, if writing it all out, the area of a rectangle is 70 inches squared. If the length is 10, find the width. Write an equation. So I need you to know that this and this are the same thing, and I need you to be prepared to find it, whether it's a picture of that rectangle or just the words, okay? So your verbal model here is that. And remember, if you have 3 unknowns, meaning 3 variables, they have got to give you, at least for right now, two of the values, so you can find the third. So what do they give you? They give you the area, they give you the length, which is 10, and then they don't give you the width. That's what you are to find. And then it's going to turn into one of those 4 simple equations. So you need to know that you need to divide and show your work to solve. Okay? That was that one. You also need to know that the area of a triangle is half of that base times the height. So I might say, if the base is 12, find the height if the overall area is 30. Okay? Yeah, it's a whole lot nicer when they give you a picture of a perfect little rectangle or triangle and the X here. It's a little harder to figure out with just the words. So you know what? Draw a picture if you want. Here's the triangle, here's the base, here's the height, and here's the area. Now find it. So your area is equal to 1/2 times the base times the height. 3 unknowns, they have to give you 2 of them. They give you this one. This is just part of the equation. They give you this one. They don't give you this one. Okay? There's 3 things to multiply. You multiply whatever order you want to multiply it in. I just took half of 12 because it was easy. So I just said that 30, half of 12 is 6. Multiply that times the height. Divide by 6. The height of that triangle is 5. Okay? You with me? All right, let's do these last 4. Caves. Oh my gosh, like drawing a picture. You ever hear a picture is worth 1,000 words? Like a picture is so helpful. So here's a picture that I drew. Here's a cave, and this is the, which one? Cumberland Cave in Tennessee is 44.4 kilometers. So this is Cumberland. And D, not a G, and this is 44.4 kilometers. It's a long cave. All right? Then there's another cave, except it's not as long as this cave, okay? Because this cave is 10.9 longer than the other one. So guess what I'm going to do? I'm going to draw another cave, but this one is 10.9 longer than this one. Are you with me? Watch this visual here. This is so helpful. So this is the Carlsbad Cave. Okay? I don't know how long it is, but I know that the Cumberland Cave is 10.9 longer. So guess what? Don't I just want to take this X that I don't know and add the 10.9? Or you say this, well, if this one's longer, all I have to do is subtract the 10.9 from it to get this cave. And if you subtracted to get your answer, what type of problem did it start out as? An addition. So I'm looking for this equation, and that will equal the height, or the width of that, the length of that, okay? Which is why you have that, plus that, and then 33.5 is that. This is another area one. This whole area, this bocce ball court, is 1032, okay? It's really tall, or it's a narrow one. So it's 12 divided by that, and you get this 86 feet long, kind of like a football field or something. It's a lot longer than it is wider, right? Okay? I will be honest, I think these multiplication and these division ones are a lot trickier, so speed skating. See how I have this underlined here? Meters per second. meters per second, how many meters did this person run? 500. How long did it take him to run it in? 74.75. So because I divided to get my answer, and they want to know the average speed per second. She ran for 74 seconds. And in that 74 seconds, she covered this much. So how much did she run in 1 second? That's what we're trying to find. So guess what? If this is how it looks, didn't this start out over here for it to get divided by that? So that's why that equation looks like this. So for every second, 1 Mississippi, 2 Mississippi, this person covered almost 7 meters per second, which is, this is 1 meter. That's fast, right? She did 7 of these in 1 second. So for you people who run, once your momentum is up and you're cruising, it's probably not too horrible to think about, right? This last one is a little bit weird. It basically just said, you work at a grocery store and most of your time is spent stocking shelves. We go to Kroger and we see those people with the carts in the middle and they they refill the granola bars and they refill the whatever. 3/5 of your time actually is spent. So if one week you work 20 hours, how many hours did that mean you actually were spent stocking and not on cash or whatever? There really wasn't a good equation. You just had to write 3/5 of 20. And when you put 20 over 1 and you cancel, you get 12. Easy peasy. All right, this next one, let's look at this. Yoga class. You guys should be flying through these double ones by now, are you? Are you really starting to look at that and know right away which one has the variable and which one doesn't? So I go to take a yoga class. I buy a mat. You can't do yoga without a mat. So right off the bat, my cost is already $19.95, and I haven't even taken one class yet. And it's $10 for every class after that. If you have Y and X, that's okay. It's just not as easy, because then when I had to plug in $139.99, I wanted to put it in for C, for cost. If you just had Y equals, it might not be as easy to know, okay? So 12 classes. Now, this one's a little tricky because it says, it starts right out and says, your library, your school has $1,200 grant. So let's say Mr. Patrick, or what's his name? Mr. Patrick is his first name. Mr. Taylor, when you have 2 first last names. Mr. Taylor says, hey guys, Seats kids, I want to get you guys some new stuff for the library. I can order books, or I can get some magazine subscriptions. Why don't you give me the title of all the books you want? And so every kid turns in an order, and the total amount of books that kids come up with is 870. So you know what he says? He says, well, I have a $1,200 budget, so first thing I got to do is take that $1,200 and subtract the 870. That's how much I get to spend on magazine subscriptions. Oh, and by the way, each magazine subscription is $30. So what am I going to do? Divide that by 30, and that's the number of subscriptions. So did you get 11? So how did you walk through that? You said the cost is equal to the $870 that in books plus 30 per magazine, and then plug in 1,200 right there, and you should get 11. Number 21, this last one was a little confusing because it actually gave you the verbal model. You just had to know that these two numbers together was your walking rate. So see how it says miles per minute? You did 1 mile in 17 minutes, okay? You have a 18-mile trail hike. You already did 5 of it, so you have 13 to go. If you're going to walk 13 miles at this rate, how long is it going to take you? Okay, now watch how you did that, though. I know what you did. You said 1/17 m, oh yeah, plus the 5. So watch, total trail minus what I already hiked, 13 left to go, and I'm doing it at a pace of 1/17 of a mile. How do I get rid of a rational coefficient? Ben? Division, but do I really want to divide by a fraction and have a complex fraction? What's better? That'll work. I want to multiply by the Reciprocal, which is, what is the reciprocal of 1 over 17? 17 over 1. So 13 times 17 gives you that, but that's not my answer. That's how many minutes. But because this book is tricky, they're not going to say how many minutes. It's going to say what? How many hours will it take you? Oh, so that's minutes. How do I get to hours? How many minutes are in an hour? So which operation? Divide by 60. 3.7 hours you have to walk. Now, that's assuming that you walk at the same rate of 1/17 per mile, the whole 3.7 hours. What if you decide to go a little faster than that? What's going to happen to that number? It'll drop because you're making up time. What if you stop and take a snack break? It's going to go up unless you sprint. So do you understand why you have to keep that pace the whole way? Which is really hard to do. Could you walk at the same speed, exact same speed for 3? Probably not. That's weird. Can you ride your bike? Sometimes when I'm driving in a car, it's like a fun game to try to keep my speed at the exact speed limit. But sometimes if it's 55, it'll go to 56 a little bit or down to 54. It's hard to do. So I'm playing that up because that's important. All right, so let's say the last one, you have a pool and the capacity is 106 gallons on this kid's pool, okay, of water. Right now, there's 15 gallons in it, okay? And you put a hose in it, and you got to sit there and wait to fill this up. And the rate that it's filling up is 2 gallons per minute. Picture a gallon of milk sitting in your fridge right now. Pour 1, pour 2, 1 minute went by. Okay, you got 2 gallons. Pour 1, pour 2, another minute. Like, whoa, that's going to be a lot. So, here's what I'm going to say. The gallons in the pool are equal to the amount that's already in there, and I'm filling it at a rate of 2 gallons per minute. Now, be careful because it says, write an equation. Oh, there's your equation. How many minutes till it's full? You have to read into that. What piece of information from the first sentence do we need? That. Full is 106. Where does 106 go? In for G. I wanted to point the difference out. Y equals 15 plus 2x and G equals 15 plus 2m mean the same thing. But this gives us a little more information, doesn't it? So I know that G is gallons, and I want to put G right there. So I do 106. And I get 45.5 minutes. That's a long time to be sitting there. 2 gallons, another minute. 2 gallons, another minute. Okay? All right. So that is